yeah, let's talk about Avail and how the architecture looks like and what are the kind of use cases that it enables. So, uh, just before we go into the agenda about what are the things that we will be covering, I'm Prabal. I am a co-founder along with Anurag. Anurag was previously a co-founder of Polygon. Um, Earlier this year, we took Avail out of Polygon as a spin-off and to create a separate entity. We want to create a credit neutral base layer for roll-up chains. And in this talk, we will mainly cover, how blockchains are changing. What is it that we are building? How does it look like? How are we trying to solve the problem of data availability? What the base layer constitutes of? How does the light plan network look like? And then what all of this means? What does it enable? What are the kind of use cases that it enables? Where are we are in terms of development and the timelines and the future optimizations in terms of how we can improve and so on and so forth. So yeah, I think till now you guys have already heard a lot about how in typical the roll-ups are like taking the center stage, and we have already recognized them being the main way to scale computation. And what a rollup is basically it acts as a validating bridge, which primarily allows people to do off-chain execution with Ethereum assets. Right? So that's how the rollups in the Ethereum ecosystem are kind of scaling the Ethereum um, computation. In terms of blockchain constructions, we are inherently seeing more and more modular constructions where people are taking a single piece of this entire stack and optimizing them and making them more efficient in ways and means in which they can speak to each other, communicate with one another, and be more efficient at the particular problem they are trying to solve. And the one of the main caveats of this entire construction is that they are only talk about who will scale the computation and where how the execution scaling works. But there is another problem which needs to be solved in tandem, which is how will the data scale? And that is where we come in. And the rollups are hungry for data availability, and we are trying to design a base layer which is optimized to solving that exact problem. The main key takeaway that we have is that every base layer blockchain is eventually going to be a DA layer. We are seeing Celestia, thanks to them for hosting the summit, and they are creating an L1 which is focused on DA. We are also seeing newer EIPs coming in, where Ethereum is trying to transition from being an execution focused chain to being more DA focused chain. And this trend is only going to be more and more as people try to bring more applications to the blockchain space. So what is Avail and how does it come in and fit into this picture? So Avail is a base layer. It provides one simple thing, which is raw block space for the rollup chains to use. It makes sure that the particular data that is submitted, that they are sequenced and packaged into blocks and published. Now, what this means is that it it only makes the data available for a short period of time, so that validity proofs or fraud proofs for the execution can be verified and be usable for later. And how it works is that it segregates the transactional data on a per app basis so that multiple rollups can publish all of them at the same time. But each of these individual applications can query only their own part of the data. Now, how Avail is bootstrapped and secured is that it will have a robust validator set that will sign off published blocks, but they do not do any execution in terms of interpretation of the data that is submitted to them. So it is very dumb in that sense. It takes only the blobs and just makes it available. And each rollup, which is built on top of Avail, has to interpret its own transactions. And they can be completely custom. We will talk about app-specific rollups and such. But just to give you a overall picture, it can be anything from EVN to being no VN at all, which is extremely custom and very circuit specific. But how does it Avail work? Is that the light clients, they leverage KZG polynomial commitments, erasure coding, and DAS to allow the verification by downloading a very small sample of the data, but not having to download the entire data by itself. And what this means is that they can download all transactions for a single application rollup, and they enable the application full nodes, but they do not have to download other application data anymore. So there can be only light clients which download only a small chunk, which is by random sampling, but there can be application full nodes which download only the application specific data and not have to download other application data. But what does it mean? Is that it means that a vibrant ecosystem can be built on top. Different types of rollups can sit on top of Avail. They can be adapted for their own unique needs. Anything like Validiums and N3 ecosystems can be built on top. You can have many types of bridges. I think there has been recently many talks about what is it, that does it mean for one thing to be a rollup. We call it a rollup. It can mean many things depending on where you're coming from, interpretations and such, definitions of how you define security, how you define liveness and things like that. But no matter how you think about a rollup, all of this can come together and work on top of a rollup. And what this also means is that state validating bridges, the strongest type of interoperability right now available, that is also possible, and this allows for asynchronous composability across the rollups which work on top of Avail. And because of this, because you all use the same DA layer, they can have shared security. So applications which are building on top do not need their own validator set. You are already seeing like rollup as a service, this kind of infrastructures where you just do one-click deployments of newer chains. This is all possible because they don't have to think about how to bootstrap their own security, as the base layer takes care of the security. And in the base layer, how does it all work? So essentially, it's very simple. It's almost like every other blockchain, how it works, but with a twist about how exactly the block construction looks like. So when the original data comes, they are packaged into a block, but instead of sending it as it is, it's actually erasure coded, and then a commitment of the data is pushed into the header. The header, along with the block, the entire block gets sent to all the validators who sign it off, and then they reach consensus on this particular block to ensure that it is present with all the validators and the full nodes. But this is not where it ends, because this would have meant that this is just another blockchain with no scalability benefits. So we will have light clients which do the sampling, but I will come to that. In general, for the block production itself, the applications send all the data blobs to Avail using a particular application ID. These blobs are chunked together and a particular 2D matrix is populated. They are segmented according to the app ID. The row-wise commitments are generated. Erasure coding is performed on the commitments, and the homomorphic property of KZG, it ensures that commitment of the erasure coded data is the same as the erasure coding of the commitment itself. The matrix is adjusted according to demand. So when the demand is low, the cost is low, the block sizes are low, and so on and so forth. But the demand is high, it kind of grows up to a particular point. The header, it contains only the commitments, the app index, and the sizes of the matrix. So this is what I was trying to mention, is that we have the data, it's broken up into this 2D matrix. They are extended column-wise to make sure that there is extended data and enough redundancy. We go ahead and commit to each of these rows to create these commitments. But the nice thing about KZG is that if you only have this particular side of the matrix, you can just produce the commitments and extend the commitments and you do not have to extend each of these columns individually. And how does the base layer stack look like? We have built the main blockchain using Substrate, which is highly performant. And in this consensus, we use Grandpa and Babe together. So essentially, in consensus systems, there is this availability family dilemma, which means that you cannot be highly available and still have instant finality. So just to kind of address that situation, we have Babe, which is the block production engine, which has been optimized for liveness. We have Grandpa, which is the finality gadget. And the leader election is based on a verifiable random function. And the finality is not reached on blocks, but on chains, which means that even if the finality holds for a particular amount of time, when enough people come back up, when 2 by 3, when more than 2 by 3 is available to finalize blocks, they can actually finalize an entire chain and not have to do it block by block. And what this essentially means is that it is tolerant against temporary network partitions and a large number of nodes crashing. What this also means is that we have nominated proof of stake, which is a little bit different from delegated proof of stake, where we see that when people come with large stakes, they inherently get larger powers. This means that they get larger rewards, and that leads to stake concentration, which essentially means that even though we have a very powerful base layer, it essentially turns out to be very lopsided in terms of power accumulation. And to avoid that, we have something like fragment election, which has proportional justified representation in terms of nominators, and nominators can choose not a single validator, but have a ranked choice of validators. This allows for high decentralization factor due to fair distribution of rewards, and that allows us to have around 1,000 validators in the active set who participate in finality of the chain. Now, coming to the light client network, the light client network, what it does is that we can have potentially millions of light clients. The light clients will all do very small amount of work individually, but collectively they will have sampled the entire block and much more with redundancy. So even if a validator goes rogue and tries to withhold data, the light client network has a peer-to-peer network of its own, which means that the replica of a block always remains available there, and it can be reconstructed from the peer-to-peer. So we have built the light client from scratch. We have built in Rust. It forms an overlay peer-to-peer network. It samples and uses the full node only for initial bootstrapping. But on the back end, like it uses a Cadendia based DHT, which contains cell level proofs, so anyone can verify the correctness of the samples. And when we scale up with more and more light clients, more and more data can be digested as part of Avail blocks. And there is no need to trust the validator set for the availability of the data. The light clients can perform data availability sampling and verify availability, even if the super majority of the validators of Avail wants to suppress the data. And that is a powerful construct, right? Because that means that once enough light clients have sampled, the data remains available, and there is no need to rely on a centralized RPC providers for getting any guarantees when you are using Avail. And that's a stark difference from how you use traditional blockchains today. And not only that, what we are doing is we are adding DA support to wallets where they verify both execution correctness and data availability guarantees to make sure that you do not have to rely on crypto economic guarantees for the correctness of the data or the data availability. You only have to rely on them for ordering. In terms of performance, this is a bit dated. Last week or 10 days back, we released an improvement where commitment times have been improved by around 70%. So this has been reduced much further. Currently, we have the 2 MB block size with a few tens of milliseconds for building commitments. But we have tested up to 128 MB and beyond, and it works. So KZG and so on is not going to be the bottleneck. The bottleneck is coming down to block propagation and such. So that's what we are trying to look at right now. In terms of what it enables is that it enables sovereign rollups, validiums, optimistic chains, and so on. I will talk about them in a minute. But what it also enables is that you can have custom execution and custom state, which means that you can deploy applications which are very, very close to what you just need for your application. But on the other hand, you can also opt for Ethereum virtual machine or Solana or anything of that sort, any standard virtual machine you can implement. And we also have, support for, let's say, Linux or some of the other execution environments as well. In terms of validiums and optimistic chains, there is a data attestation bridge which is live on testnet. What it does is that it takes the attestations from Avail and pushes it to Sepolia network for now, but you can basically plug it into any settlement layer, and then you can run a validium on top, where the validium kind of just sends the proofs or the fraud proof or a lack thereof to Ethereum, and all the data availability guarantees are provided by Avail through the attestation bridge to Ethereum or other networks. And that's how you can not only build like L2 validiums on top of Ethereum, but you can also have L3 validiums on top of L2 chains. This also provides the basis for sovereign rollups. What that means is that today you will see that most rollups rely on a settlement layer for validating execution proofs, but they can also be doing very well on a light client. And the L1 way of doing things is hard to upgrade, or you have to have a multi-sig and things like that. Social consensus is probably not possible because you need an L1 to fork it and so on. But for sovereign rollups that do verification directly on application like clients, they don't have to rely on a smart contract. They can upgrade by upgrading their clients, just like you upgrade an L1. And the light clients can verify not only data availability, but execution proofs without downloading all the transactional data. And many different designs which are possible in this space: optimistic, ZK, with a sequencer, with a shared sequencer, without a sequencer, all kinds of things are all possible in this domain. In terms of where we stand, we right now are closing up our long-running testnet, which is a curated testnet, where we have tested around 105 top external validators. And we have pushed huge performance improvements, as I said, a week or so back. Next month, we are going to launch our incentivized testnet, so I would welcome everyone to kind of come and participate in that. And hopefully, early next year, we will have our online net, which is our target. In terms of future optimizations, where we can improve and so on, right now, the validators can verify commitments, but every validator has to verify all the commitments from the block producer because they have to regenerate commitments. But we are trying to look at improvements where that is not the case. We already have a PR, but we are trying to test and include the multi-proof KZG commitment so that, we can generate not only cell level, but particular submetrics level openings, which will mean that there are huge improvements in terms of how the DHT is populated, how the network streams work, how the bottlenecks of the peer-to-peer are coming into effect. But this will all be backward compatible, so existing LC1 interfaces will remain the same. We are doing changes to the LC interface as well, so would welcome you guys to kind of come in and give us more feedback. In terms of the attestation bridge, we are trying to, right now it's optimistic design, but we are trying to make it a ZK snark based. The initial prototype is ready. We have already deployed it on Goldly. We are trying to polish it off along with Fuss8, and we will make sure that it works even with a very large validator set, like 1,000 validators. Yeah, that's all from me. But if you guys have questions, feel free to visit our website, the dogs, the blog. And yeah, we are also hiring. So, yeah, thanks.